I've been testing the water in this pond since early spring. When I first came out here, the water in the pond was about 50 degrees Fahrenheit in temperature, and the dissolved oxygen was about 10 milligrams per liter. I came out later when reeds were just starting to emerge from the pond, and at that point the water had warmed up to around 60 degrees, and the DO had dropped to about 8. Now that change from 10 to 8 is pretty much a function of the temperature. As the temperature of water goes up, its ability to dissolve oxygen goes down. So we would expect that to happen just because the pond is warming up. To do dissolved oxygen, you have to add a bunch of reagents and then titrate to get the amount of oxygen. And you notice how it gets cloudy. There's a chemical reaction going on in the sample now that's tying up the oxygen. You have to wait for that to happen. While we're waiting for that, we'll do pH. Notice the sample in this bottle, how green it is. That's from the algae that's growing in the pond, which will also add to the soil in the bottom of the pond. And we've done this pH before. This one is between 6 and 7. It's where we want it to be and where we would expect it to be. Now we're going to do a measurement of total hardness, which is effectively the amount of calcium in the water. These surface water springs and ponds are generally very low because the water's not in contact with the rocks. Well, the reading on the hardness is between 25 and 50, probably a little closer to 50. It goes from a green at 0 up to this pink at 425, and you can see we're in between the lighter green and where it starts to turn brown. When we're measuring hardness, what we're measuring mostly is calcium. There are a couple of other elements that are also included, but most of it's calcium. Now, calcium in water gets there from dissolving minerals in rocks, and calcium is good in an environment like this because the shells of turtles and snails and clams and all of those other critters use the calcium to build their shells. So you need to have that in the natural water in order for those organisms to survive. The crust you get on the bottom of a pan when you boil it dry, that's calcium carbonate from the hardness in the water. And we put in water softeners in houses to remove the calcium so that you don't get that. But it's a really important element to have in the environment, like I said, because a lot of organisms, even ones that you don't normally see, the ones that are food for fish, use it to make their shells. This pond actually is very low. I'm sure that most organisms would like to have a little bit more because it would be less work for them to get enough to make their shells. I put another chemical into this dissolved oxygen bottle that will convert the chemicals that are in here to iodine in an equal proportion to the amount of oxygen that was in the water to start with. So now you see this yellow-brown color. That's basically iodine in the water. And now what I'm going to do is I'm going to measure the iodine, and from that I can tell how much oxygen was in there to start with. There's a series of complicated chemical reactions that take place, and eventually what you do is you convert the oxygen into iodine. I'm measuring out an exact amount of this water out of this little bottle because when I put the final chemical into it, I have to know exactly how much water I'm using. Now this little flask contains exactly 50 milliliters, and that allows me to calculate the concentration of oxygen exactly. Okay, now this chemical reacts with the iodine and removes it from the water. And for every 20 drops of this chemical that I put in, that means there's 4 milligrams per liter of oxygen. I have to do this very carefully. You notice how the color got much lighter with just 10 drops. If you remember from grade school where you took iodine and put it on the end of a potato, back in the days when you could do that, the potato turned purple. Well, I'm going to add starch to this solution here that has iodine in it. There we go. Because there's not very much iodine in there, you can see it's just a faint purple color. Now what I'm going to do is I'm going to add a few more drops, and that purple color will go away. Now remember, that water was green to start with because it had so much algae in it, and we're probably there. So I used 15 drops, so there's only about 3 milligrams per liter of oxygen in this water, so it's very, very low. And that's what happens in the summertime in these lakes. They warm up, the oxygen is used up by the organisms that live in the lake. There would be no fish would be able to survive in that lake or in that pond water right now, because it doesn't have enough oxygen for them to survive. Even fish that like or can handle low oxygen concentrations need at least 5 or 6 milligrams per liter. And like I said, with the titration that I just did, there's about 3 in this. Probably the biggest thing that's depleting the oxygen in the pond right now is the decomposition of all that organic matter out there. All those plants that are dying and settling to the bottom or decomposing. And the bacteria that eat up those plants use up the oxygen. And so they're taking it out of the water. The pond is pretty much completely filled in with vegetation. The dissolved oxygen has gone down to about 3, and the temperature is about 70 degrees. Well, the temperature hasn't gone up that much, but the dissolved oxygen has gone down a lot, and that's because these grasses and reeds and other vegetation that's growing in here now have started to die because of the heat of the summer. Eventually all this stuff will die and will fall to the bottom, but already we're seeing the organisms, the bacteria and other organisms in the pond decomposing that vegetation, and that's lowering the dissolved oxygen below what the temperature would account for. The only other thing that we've looked at that really has much relevance is the calcium, and we've already talked about how that is beneficial for the organisms in that they can make shells with it and they need it for their metabolism. But that is a very low number, and that mostly comes from the fact that we've got a little bit of calcium being added from the decomposition of the plants, but mostly it's dissolving of all these rocks. I mean, this water with a pH of 6 is slightly acidic, and it's dissolving minerals out of the rocks that are in the pond, and those are adding to the calcium levels and other nutrient levels in the pond. This pond is basically what we would call hypereutrophic right now. It's got a lot of organisms in it. It's got algae growing in it. It's got the reeds and the grasses. It's just teeming with life, but it's not very good if you happen to be a rainbow trout or another kind of fish that likes oxygen in your water. This is what we were talking about earlier about the succession of a pond to a meadow. This is a natural part of that process. All of this vegetation growing in here eventually will fill this in. This will no longer be a low spot. It will be just a flat plain, and all of this vegetation will have decomposed into a silty soil, and trees and shrubs will start to grow in there in the place of the water-liking vegetation. Lost Pond, which is further up the trail here, is well on its way. There's a lot of organisms growing in there that don't look anything like these wetland plants. And eventually, probably in another 20 years, this will look just like Lost Pond.